In this video, we're going to look at integrating functions of the form e to the x with respect to x. So again, let's recall some facts. When we learnt to differentiate e to the x, so if y equaled e to the x, we remember that the derivative of e to the x was e to the x. Now, if we are going to anti-differentiate this, we would then say the integral of e to the x with respect to x equals e to the x plus c. Now let's recall other functions of the form where there's perhaps another power there. Let's just recall again, if we had something like y equals e to the 2x, and we differentiated that using the chain rule, we'll recall that differentiating this becomes 2e to the 2x. Now, let's just set up an integral and anti-differentiate this. So we can say, and what I want to try and do is come up with a general rule. So let's just anti-differentiate. If we set this up, we get the integral of 2e to the 2x equals this plus c. However, what we can do, let me do it in two stages. So I'll just set that up, equals e to the 2x. Sorry, what am I doing? Hold on a sec, let me just rub that off because it's not an integral. Apologies for that. Equals e to the 2x plus c. Now, what we can do with integration is we can pull out constants. So if I pull out that constant, we get e to the 2x dx. This means 2 multiplied by the integral of this becomes this. So I'm not changing anything at the moment. I've literally set up an equation. Now, we can divide both sides, because both sides need to, whatever you do to one side with an equation, you do to the other. We can say, and I think I'm going right off the bottom of the page, so I'll just talk through it. We can say that the integral of e to the 2x dx equals 1 over, or a half, 1 over 2, e to the 2x plus c. And we can generalize this by saying that the integral of e to the kx with respect to x equals 1 over k e to the kx plus c. Sorry if that merges in. All right, I'm going to clear some space and do an example. All right, so I've left our general rules here so I can do these. I'm going to do a fair few examples of these, so bear with me. So what I want to do is I want to integrate e to the 4x with respect to x. Now you'll notice there's a value in front of the x, so I need to automatically go to this rule here. K is 4, so we can just substitute the 4 in there and we can just use the rule as it is. So we can say the integral of this is 1 over 4 e to the 4x plus c. Okay? All right, let's do another example. Let's write one down. Let's do e to the 3x. We're going to integrate e to the 3x plus 6x. All right, so we've got a special function here, and then this is just part of a polynomial, this tiny bit here. So we just use our basic rules of integration for this. So again, k is 3, so we get 1/3 e to the 3x plus, and then 6x squared over 2. 6 over 2 is 3, so we get plus 3x squared, and then plus that c on the end. All right, now I'm going to do another one where I'm looking at integrating e to the x plus e to the negative x with respect to x. Now I may need a little bit more room, so 2 seconds. I think I'll be all right for space. All right, so let's look at this. This is just a straightforward following this rule. E to the x, when you integrate that, becomes e to the x. And then looking at this one, well, the value of k is -1. So we need to do -1 over 1. So I'll write this down, which of course simplifies to be the -1. E to the kx, negative x, and then don't forget the plus c. Now, if we simplify this properly, we get e to the x minus e to the minus x plus c. All right. Okay, now what I might do is look at, well, what happens if we need to find the constant? So we'd have some extra values. So I might do a question that involves a curve. All right, so this is pretty much your basic finding the constant of an indefinite integral question. That could be worded in several ways. You may be given the derivative of a function plus a coordinate or a value of x and a value of y and be asked to find the general formula y. Or it could be worded where you're given something like the gradient of the tangent to a curve is 5e to the 2x, and the curve also passes through the coordinate 0, 7.5. Find the equation of the curve. So several variations for this type of question, but pretty much what we're doing is we're finding the constant c and then finding the curve. So in order to do that, what we need to do is integrate and find what the curve would be. So if this is this gradient function, we are actually integrating 5e to the 2x with respect to x. And we will use these values later on. So I can pull the 5 out the front and just multiply my integral with that. So 5 multiplied by e to the 2x with respect to x. Now I'm actually going to integrate this, well, this value of k is 2, 5 multiplied by, so 1 over 2 e to the 2x would be that, plus c. Just tidying it up, we get 5 over 2 multiplied by e to the 2x plus c. So this is now y. And we're going to use our values of x and y here to find c. So let's substitute in. I've got 7.5 equals, well, this is technically 2.5, isn't it? 2.5 e to the 2x. I don't like using decimals, I much prefer fractions, plus c. Now, in order to do this, I now need to, I need to substitute in x is 0, so let me do that. Apologies, I didn't put 0 in there, so let's just put 0 in there. 2 multiplied by 0 obviously gives us e to the 0. Well, e to the 0 is 1. 1 multiplied by the 2.5 is 2.5, so I get 7.5 equals 2.5 plus c, and all I've got to do is subtract the 2.5 from the 7.5 to give me that c equals 4. So therefore we can now write the value of y, or the equation y, as I think I'll just squeeze that on the right at the bottom of the screen. Y equals 5 over 2 e to the 2x plus 4. That's just, so it's not really gone on the screen, apologies there. You can just understand from what I said. Alright, so sorry about that, technical issue. And that's pretty much everything you need to know about integrating functions of the form e to the x.